Okay, so now the question is asking us to find the area between these two curves here, right? So first step here is to actually graph these curves, and y equals x squared is pretty easy to graph, but this other curve, this y equals 2x minus x squared, is going to be a transformation of y equals x squared. So in order to see what transformation that is, we want to complete the square, right? So what we do is we can first rewrite this as negative x squared plus 2x, right? And then pull out this coefficient on x squared, which is just the -1, right? So this becomes, negative parentheses x squared minus 2x, right? And then, and this is an x here, and then we want to add something inside of these parentheses that will make this a perfect square. And so we add a 1, right? Because then this thing here will be x minus 1 quantity squared. But since we added this 1, right, and we're multiplying by -1, we actually subtracted a 1. So what we need to do is add a 1 back, right? And then we're preserving this inequality. I mean, this equality, right? This is equal to this. So right, so now we have that this is a transformation of the curve y equals x squared. Right, so we have a few things going on here, right? We have first starting with y equals x squared, right? We are subtracting 1 from the x term, right? So we are shifting this over to the right 1 unit, right? So 1, right? So now this is y equals x minus 1 squared, right? And then we can take that and transform it again. There's a few things going on, like I said. So first thing we want to look at is this this negative out front here, right? So that is going to flip the curve over the x-axis, right? So that you have something that looks like this, right? Not a perfect drawing, but right. So this is now the curve y equals negative quantity x minus 1 squared, right? And then the last thing is we have this plus 1 here. So we're just going to shift this graph up 1 unit, right? And that gives us, the curve looking like this. Now we see that it is going to go through the origin here, right? And we can use what we found here to, actually graph this region that is between these two curves, right? So now we have the curve y equals x squared. Let's do that a little bit better this time. Right, y equals x squared, and the curve, so this is y equals x squared, and the curve y equals 2x minus x squared, which looks like this, right? So this is our region right in here. Let's make it a little bit bigger. Right, so this is our region here. and our top function is the function y equals 2x minus x squared, right? So we say, we have yt is equal to 2x minus x squared, and yb is equal to x squared, right? And so now we want to find the, area of this region, but we don't have limits of integration yet because we don't necessarily know where these two curves meet. We do know that they meet first at 0, but we don't know where that second value is. So how do we figure that out? Well, we just have to find the intersection points of these two curves, right? Right, so we have x squared equal to 2x minus x squared, right? This is just where yt is equal to yb. Those are where the intersection points are. All right, so we just have to solve this. There's, maybe a couple of ways we could do it. Just add x squared to both sides and subtract 2x. You have 2x squared is equal to 2x. So you have 2x squared minus 2x is equal to 0. And then x squared minus x is equal to 0 when you divide everything by 2. So you have x times x minus 1 is equal to 0. Right? And that is true whenever x is equal to 0, right? Or x minus 1 is equal to 0, so x is equal to 1. Right? So these are our intersection points, right? So now we have our, we know what our top and bottom function is, and we know the limits of integration are 0 and 1. So we have, this is the integral from 0 to 1 of 2x minus x squared, right? That's our yt, minus x squared, that's our yb, right? And now it's just a matter of actually integrating, right? So let's kind of center this here. Right, so we can just kind of get rid of those parentheses there and combine those like terms. And we use our power rule. Right, and then plugging in. First, these cancel here, so I could do that first. This is 1 minus 2/3, 1 squared minus 2/3 times 1 cubed, right? Minus 0 squared minus 2/3, 0 cubed. And we know this whole thing is going to be 0. So this is just 1 minus 2/3, which is, of course, 1/3, or 1/3.